Alright, today we are doing 15.4 notes, square root functions and transformations. So let's start by looking at what the square root function looks like, and real quick we'll just mention what each of these mean, which should be familiar to us. So here's our basic square root function, y equals a square root of x minus h plus k. So that a is going to tell us, one, if there was a reflection. So usually if there's not a reflection, it's going to look something like this where it curves up. But if there is a reflection, then it will curve down, kind of like that. And then the second thing A tells us is whether there was a stretch or a shrink. Then that H value, that H tells us whether it went left or right. Just like all the other functions we've looked at, we have to think of opposites here. So if it is a negative h, if it's x minus a number, then that tells us it went right. So I'm going to put a negative over it. Negatives usually we would think make us think left, but a negative actually tells us that instead of starting here at 0, 0, we moved it somewhere to the right. If that's an x plus h, that means it was moved to the left. So remember, for these we're going to think opposites. And then for that k value, hopefully you know that that means it went up or down. And the k, it does exactly as we expect. If it's a positive k, then that means instead of starting at 0, 0, the function was moved somewhere up. And if it's a negative k or a minus k, then that means the function was moved down. Last thing that this tells us is the starting point. So on this one, we see, I know this graph is small, but we see this is our starting point. That's where the function starts, and then it goes forever and ever this way. Well, the starting point we actually get from hk. So the starting point is an ordered pair hk. Notice that we take the opposite sign. So in here we have x minus h, it's a negative h, and we took a positive h, okay? So we are going to look at transformations in a bit. First we want to actually graph. So you will need a calculator on your phone or on your Chromebook. You could also use Desmos.com, and all we're going to do is type these in. Before we do that, I want to talk about what happened with this function. So we have y equals negative square root of x plus 2. Well, that negative tells us that instead of curving up, it was reflected and it will curve down. So that's what the negative means. That positive 2 tells us that it went left 2. Remember, the inside is right or left. We have to kind of think opposites. And what's the starting point of this? The starting point will always be the first point in our graph. So I'm going to put SP for starting point. Well, the x value of this starting point, we look inside and we see a positive 2, so we take the opposite, negative 2. And then there's actually no k value here, so that means our y is 0. So our starting point is negative 2, 0, and we'll see that when we graph it. So let's go to our calculator. First thing I want you to do is clear your calculator. So second plus 7, 1, 2. Now that it's cleared, we will go up to this y equals so that we can graph. And we want to type in negative. And then the square root button is right here. We have to press the second, and it's above. You see there's a little blue square root above x squared. So second x squared. So we have the square root of x plus 2. So I'm just typing that in. Now that I typed it in, we are going to go to the graph. We kind of see what it looks like. It's curving down. Here's where it starts. And we need our table. So we'll go second, graph, there's our table. So I actually want you to scroll until you find the starting point. The starting point is negative 2, 0. So I'm going to scroll up, and you'll see that above that, it says error. And that's because if I plug in any of those x values to this, like if I plug in negative 5 plus 2, that gives me a negative 3, and we can't have a negative under the square root at this point. So that means any number with error is going to give us a non-real solution. All right, so negative 2, 0 is our first point, and I only want you to write down the nice points. So no decimals or fractions. Then I see negative 1, negative 1. We're going to scroll down. I see, 2, negative 2. Keep going. I see 7, negative 3. And I think that's all that will fit on our graph. So now that we have our table, let's graph it. We have -2, 0. Then we have -1, -1, 2, -2, and 7, -3. So here is what our square root function looks like. Let's do one more of these graphs. I want you to try it on your own, find the table, and then check it with me. All right, here you see I've typed in my function. One thing that's a little bit tricky is that you put the 2, the square root of x minus 1. After you type the 1, you have to do the right arrow to come out of the square root and then type that -2. So make sure that -2 is outside of the root like this. All right, so I did that. I went to the graph. This time we see that it opens up, and you'll see that I actually already wrote down my table. This starting point, I got it from here. The h value is -1, so we take a positive. The k value is -2, and that's what we take. So let's graph it. We have 1, -2, 2, 0, 5, 2, and 10, 4. So here is our function. And you'll notice that this is kind of like a sideways half of a parabola. So we know that parabolas look like this. When we do square root functions, we turn them on their sides and we just take the part that will make underneath the root positive. So actually, to tell that we have a stretch here, because that 2 is a stretch, the way we can tell that is how do we get from the first point to the second point. So in a function that does not have a stretch, we'll see this one. This one didn't have a stretch. To get to the next point, we went over 1 and then down 1. Or if it was opening up, we would have gone over 1 and up 1. This one has a stretch. The way we can tell without this function is we went over 1 and up 2. So we just look at these first 2 points to tell if we have a stretch or a shrink. And we'll talk more about that right now. All right, next one. For each graph, list the transformations from the parent function y equals the square root of x. So here is our graph. We see that our starting point is here at -2, 3. Well, what does that mean? Usually our starting point is here at 0, 0. So we are trying to find what happened to get from here to here, and then was it stretched, shrunk, or neither? Excuse me. All right, well, to get from here to here, we actually went left 2 units. Because we start at 0, 0, we went left 2, we went up 3. Was it reflected? No, if it was reflected, then it would open down like that. But that's not the case here. So it was not reflected, and then was it stretched or shrunk? Well, we go over 1 and up 1. That is our regular function. If we go 1, 1 for the first part, that's regular, so there's no stretch or shrink. And let's actually go ahead and write this function. There's no stretch or shrink, which means there's no a value. It wasn't reflected, so it's not going to be negative. So we can just start with the, not absolute value, I'm sorry, the square root of x. It went left 2 units, so that means it's going to be x plus 2. And it went up 3, so it'll be plus 3 on the outside. All right, next one. We are looking for the transformations from the parent function, which starts at 0, 0. So this time it went right 1. So it went right 1 unit and it went up 1, 2, 3 units. And on this one, let's look. We go over 1 and up 2. So what does that mean? Because this one had no stretch or shrink and we went over 1, up 1. This one, we go over 1, up 2, which means it was stretched by a factor of 2. This one was not reflected because it curves up. A reflection means it curves down. Last thing, let's write the function. It's not a reflection, so it's not negative. It's stretched by 2, so we start with 2. Then the absolute value of x. Right 1 unit tells us plus 1. Oh, I'm sorry, that tells us minus 1. And that's where we have to be careful. X minus 1, and then up 3 means plus 3 at the end. I want you to try the last one on your own and then check it with me. All right, here's the last one. This is usually where the parent function starts, so our starting point is actually down here, which means it went left 1, down 2, and I said stretch by a factor of 3. Why is that? Because from our first nice point to our next one, we went over 1 and up 1, 2, 3. So that tells us to stretch by 3. That means our a value is 3. Left 1 unit tells us x plus 1 under the root, and down 2 tells us minus 2 on the outside. All right, next question. Without graphing, list the transformations from the parent function for this one. Well, that we have negative 5 square root x minus 4. That negative tells us reflection over x-axis. Oops. That's what the negative means. Now the 5, because that 5 is bigger than 1, that means a stretch. If this was negative 0.5, negative 0.3, negative 1/4, any of those would be a shrink. Negative means reflection, and then that 5 tells us stretch. Stretch by a factor of 5. All right, next thing, on the inside we just have x, so it was not moved left or right any, but that negative 4 means down 4 units. And before we finish up, I actually want us to go back to our graphs and talk about domain and range. So first we'll do our domain here. The domain, remember, is our x values. So our domain, I'm going to start with x such that, remember that's the same as writing x is an element of the reals, such that blank. So either of these are good for your beginning part. Well, we want to trace our x values. What x values are being covered here? So such that our x's start here at negative 2. And then our graph goes this way forever and ever. So no x values over here are covered. We start at negative 2 and we are actually going to the positive x values. So that means x is greater than or equal to negative 2. Then we have our range. Our range is our y values. So I'm going to start with y such that, and again that's the same as having y as an element of the reals such that. We want to trace our y values here. Well, our y values are the up and down values, so it starts here, or I guess it stops here at 0, and it's going down, 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 down forever and ever and ever. It's slowly working its way to the negative y's. So that means y is less than or equal to 0. Well, let's look at the function and how we can tell these are going to happen. The x values are actually always going to be greater than or equal to, because we're always going to have our function going this way, because we have to have the inside be positive. This negative 2, this number will come from the x value of your starting point. The number for the y value will come from the y value of your starting point. And then this sign here comes from if there's a reflection or not. This one was reflected. That negative sign tells us it curves down, which means that will be a less than or equal to. Let's look at this one. First of all, our domain. For the domain, we start with x such that we said that x is always going to be greater than or equal to, and we said that we can actually just take the x value of our starting point and put it there. Well, let's look at our function to make sure it matches. The domain is x is an element of the reals such that x is greater than or equal to 1. Well, we see our x value starts here at 1, and it goes this way forever and ever to the positive x values. So yes, that is greater than or equal to 1. Then our range, y such that y is greater than, or is it less than? Was this one reflected? No, this one is going up, which means it starts here and it goes up forever and ever and ever. So y is greater than or equal to the y value of our starting point, negative 2.